Find all complex solutions, real and non-real. Enter your answers as a comma-separated list. The function we have is x cubed plus 13x squared plus 52x plus 70, which is equal to 0. So from the rational zeros theorem, the rational zeros are the form of plus or minus p over q, where p is the factor of the constant term, which is 70, and q is the factor of the leading coefficient, which is 1. So we know that the constant term is 70 and the leading coefficient is 1. So what are all the factors of 70? Well, all the factors of 70 are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 7, plus or minus 10, plus or minus 14, plus or minus 35, and plus or minus 70. And so then what we're going to do is we're going to divide it by the factors of the leading coefficient, which is plus or minus 1. So if we divide everything by 1, then what we're going to get are what we have in the numerator, which is plus or minus 1 all the way to plus or minus 70. So the first thing we want to do is we can try each one of these values by using synthetic division, but we can shorten it up just a little bit by trying to find out using the remainder theorem by plugging each one of these values. So if we plug in the first value, which is 1, so let's find f of 1, and we're going to plug that into the function. So it's going to be 1 cubed plus 13 times 1 squared plus 52 times 1 plus 70. Okay, if we plug that into our calculator, then we get 136, so we know that that is not a 0. If we try f of negative 1, we get negative 1 cubed plus 13 times negative 1 squared plus 52 times negative 1 plus 70, and that gives us a value of 30, so therefore we know that that has a remainder, so therefore it's not a 0. And if we try f of positive 2, we plug in 2 and then cube it, plus 13 times 2 squared, plus 52 times 2, plus 70, and that gives us 234. So again, that is not a 0. If we find f of negative 2, we get negative 2 cubed, plus 13 times negative 2 squared, plus 52 times negative 2 plus 70, and that gives us a value of 10. So now we're going to move on to 5. So if we want to find f of 5, we plug in 5, cube it, plus 13 times 5 squared, plus 52 times 5, plus 70, and that gives us 780, so that is not a 0. If we find f of negative 5, plug in negative 5, cube it, plus 13 times negative 5 squared, plus 52 times negative 5, plus 70, and that gives us positive 10. So now we're going to try f of 7. So we get 7 cubed plus 13 times 7 squared plus 52 times 7 plus 70, and that gives us 1,414, which again is not a 0. And now let's try f of negative 7. So negative 7 cubed plus 13 times negative 7 squared plus 52 times negative 7 plus 70 gives us a remainder of 0. So we know that negative 7 is a 0 of this function. So what we're going to do is we're going to use that negative 7, and then we're going to use synthetic division to find the other factor. So we have negative 7, and then we're going to use the coefficients of this function. So we have 1, we have 13, we have 52, and then we have 70. So in this, we're going to bring down the 1. So we have negative 7 times 1. And so negative 7 times 1 gives us negative 7. And 13 minus 7 is going to give us positive 6. Negative 7 times 6 is going to give us negative 42. And 52 minus 42 is going to give us 10. And negative 7 times 10 is going to give us negative 70, which gives us that remainder of 0. So what we want to do is now we want to focus on this factor here, which is 1, 6, and 10. So we know that for the most part right now, we know that x plus 7, because this is minus 7, is a factor. And then here, this is going to be x squared plus 6x plus 10. So we know that x squared plus 6x plus 10 is the other factor. So far, we know that the zeros we found, one of them is negative 7. Okay? So what we need to do is we need to factor x squared plus 6x plus 10. So since we need to factor this, okay, first and foremost, if we take the 10 and then we have 6, are there two numbers that we can multiply to get 10 and when we add them together it gets 6? We don't. So we're either going to have to complete the square or use the quadratic formula. So I'm going to go ahead and then complete the square. And so we're going to let x squared plus 6x plus 10 equals 0. And then we get x squared plus 6x, which is equal to negative 10. Now again, you can use the quadratic formula if you want as well. So we have plus n here and then plus n here. And so then n is going to equal 1/2 of b and then squaring it. So we know that b is 6. So we want to take 1/2 of 6, which is 3. And then we square that to get 9. So therefore, we have x squared plus 6x plus 9, which is equal to negative 10 plus 9. And so therefore, we know what did we have to square to get 9, which is 3. So when we factor this, we get x plus 3 squared, which is equal to negative 10 plus 9, which is negative 1. And now we can solve by taking the square root of both sides. Okay, so we have x plus 3 squared, that becomes x plus 3. And the square root of negative 1 is I. Now remember that this is plus or minus, so this is plus or minus I. So therefore, x is going to equal negative 3 plus or minus I. So that means that we have two factors there. We have negative 3 plus I and negative 3 minus I. So therefore, in step 5, the other two zeros are negative 3 minus I and negative 3 plus I.